Chapter 7. Thermal Properties of Matter. Exercises page 140. Exercises Q1. Page 140. Choose the correct option. Range of temperature in a clinical thermometer, which measures the temperature of the human body, is 1. 70 C to 100 C2. 34 C to 42 C3. 0 F to 100 F4. 34 F to 80 F. Solution. 34 C to 42 C. Exercises Q1. Page 140. Choose the correct option. A glass bottle completely filled with water is kept in the freezer. Why does it crack? 1. Bottle gets contracted. 2. Bottle is expanded. 3. Water expands on freezing. 4. Water contracts on freezing. Solution. Water expands on freezing. Exercises Q1. Page 140. Choose the correct option. If two temperatures differ by 25 degrees Celsius on Celsius scale, the difference in temperature on Fahrenheit scale is 1. 65 degrees 2. 45 degrees 3. 38 degrees 4. 25 degrees. Solution. 45 degrees. Explanation. 100 divisions on Celsius scale correspond to 180 divisions on Fahrenheit scale. Exercises Q1. IV page 140. Choose the correct option. If alpha, beta and gamma are coefficients of linear, area L and volume expansion of a solid, then 1. Alpha, beta, gamma equals 1. 3. 2 2. Alpha, beta, gamma equals 1. 2. 3 3. Alpha, beta, gamma equals 2. 3. 1 4. Alpha, beta, gamma equals 3. 1. 2. Solution. Alpha, beta, gamma equals 1, 2, 3. Exercises Q1. B page 140. Choose the correct option. Consider the following statements. The coefficient of linear expansion has dimension k1. 2. The coefficient of volume expansion has dimension k1. 1. I and 2 are both correct. 2. I is correct but 2 is wrong. 3. 2 is correct but I is wrong. 4. I and 2 are both wrong. Solution. I and 2 are both correct. Exercises Q1. B page 140. Choose the correct option. Water falls from a height of 200 meters. What is the difference in temperature between the water at the top and bottom of a waterfall given that the specific heat of water is 4200 J kg minus 1 degree Celsius minus 1? 1. 0.96 degrees Celsius. 2. 1.02 degrees Celsius. 3. 0.46 degrees Celsius. 4. 1.16 degrees Celsius. Solution. 0.46 degrees Celsius. Explanation. The potential energy at height equals kinetic energy at bottom. Assuming all kinetic energy is converted into heat, let delta T be the rise in temperature of water observed at the bottom. Exercises Q2. Page 140. Answer the following question. Clearly state the difference between heat and temperature. Solution. Heat. Temperature. 1. Heat is energy in transit. When two bodies at different temperatures are brought in contact, they exchange heat. OR. Heat is the form of energy transferred between two or more systems or a system and its surroundings by virtue of their temperature difference. Temperature is a physical quantity that defines the thermodynamic state of a system. OR. Heat transfer takes place between the body and the surrounding medium until the body and the surrounding medium are at the same temperature. 2. Heat exchange can be measured with the help of a calorimeter. Temperature is measured with the help of a thermometer. 3. Heat, being a form of energy, is a derived quantity. Temperature is a fundamental quantity. 4. SI unit. J. Joule. SI unit. K. Kelvin. 5. Dimension. L2M1T2K0. Dimension. L0M0T0K1. Exercises Q2. Page 140. Answer the following question. How a thermometer is calibrated. Solution 1. For the calibration of a thermometer, a standard temperature interval is selected between two easily reproducible fixed temperatures. 2. The fact that substances change state from solid to liquid to a gas at fixed temperatures is used to define reference temperature called a fixed point. 3. The two fixed temperatures selected for this purpose are the melting point of ice or the freezing point of water and the boiling point of water. 4. This standard temperature interval is divided into subintervals by utilizing some physical property that changes with temperature. 5. Each subinterval is called as a degree of temperature. Thus, an empirical scale for temperature is set up. Exercises Q2. Page 140. Answer the following question. What are different scales of temperature? What is the relation between them? Solution. Celsius scale. 1. The ice point melting point of pure ice is marked as 0 degrees Celsius, lower point, and steam point boiling point of water is marked as 100 degrees Celsius, higher point. 2. Both are taken at 1 atmospheric pressure. 3. The interval between these points is divided into 100 equal parts. Each of these parts is called as 1 degree Celsius and it is written as 1 degree Celsius. Fahrenheit scale. 1. The ice point melting point of pure ice is marked as 32 degrees Fahrenheit and steam point boiling point of water is marked as 212 degrees Fahrenheit. 2. The interval between these two reference points is divided into 180 equal parts. Each part is called a degree Fahrenheit and is written as 1 degree Fahrenheit. Kelvin scale. 1. The temperature scale that has its 0 at 273.15 degrees Celsius and temperature intervals are the same as that on the Celsius scale is called as Kelvin scale or absolute scale. 2. The absolute temperature, T, and Celsius temperature, Tc, are related as T equals Tc plus 273.15 e.g. When Tc equals 27 degrees Celsius, T equals 27 plus 273.15 K equals 300.15 K. Exercises Q2. IV page 140. Answer the following question. What is absolute zero? Solution. Graph of pressure versus temperature, in degrees C, at constant volume. Graph of volume versus temperature, in degrees C, at constant pressure. 1. When the graph of pressure P against temperature T degrees C, at constant volume for three ideal gases A, B, and C is plotted, in each case, PT graph is a straight line indicating direct proportion between them. The slopes of these graphs are different. 2. The individual straight lines intersect the pressure axis at different values of pressure at 0 degrees Celsius, but each line intersects the temperature axis at the same point, i.e., at absolute temperature, minus 273.15 degrees Celsius. 3. Similarly, graph at constant pressure for three different ideal gases A, B and C extrapolate to the same temperature intercept minus 273.15 degrees Celsius, i.e., absolute zero temperature. 4. It is seen that all the lines for different gases cut the temperature axis at the same point at 273.15 degrees Celsius. 5. This point is termed as the absolute zero of temperature. 6. It is not possible to attain a temperature lower than this value. Even to achieve absolute zero temperature is not possible in practice. Exercises Q2. B page 140. Answer the following question. Derive the relation between three coefficients of thermal expansion. Solution. Exercises Q2. B page 140. Answer the following question. State applications of thermal expansion. Solution. 1. The steel wheel is heated to expand. This expanded wheel can easily fit over axle. The wheel is then cooled quickly. Upon cooling, wheel contracts and fits tightly upon the axle. 2. An electric light bulb gets hot quickly when in use. The wire leads to the filament or sealed into the glass. If the glass of the bulbs has significantly different thermal expansivity from the wire leads, the glass and the wire would separate, breaking down the vacuum. To prevent this, wires are made of platinum or some suitable alloy with the same expansivity as ordinary glass. Exercises Q2. B. Page 140. Answer the following question. Why do we generally consider two specific heats of a gas? Solution. 1. A slight change in temperature causes a considerable change in pressure as well as the volume of the gas. 2. Therefore, two principal specific heats are defined for a gas, viz. Specific heat capacity at constant volume, SV, and specific heat capacity at constant pressure, SP. Exercises Q2. B. Page 140. Answer the following question. Are freezing point and melting point same with respect to change of state? Comment. Solution. Though the freezing point and melting point mark the same temperature, 0 degrees Celsius or 32 degrees Fahrenheit, state of change is different for the 2 points. At freezing point, liquid gets converted into solid, whereas at melting point solid gets converted into its liquid state. Exercises Q2. X page 140. Answer the following question. Define sublimation. Solution. The change from solid state to vapor state without passing through the liquid state is called sublimation and the substance is said to sublime. Exercises Q2. X page 140. Answer the following question. Define triple point. Solution. The triple point of water is that point where water in a solid, liquid and gas state coexists in equilibrium, and this occurs only at a unique temperature and a pressure. Exercises Q2. Sheet page 140. Answer the following question. Explain the term steady state. Solution. 1. When one end of a metal rod is heated, the heat flows by conduction from hot end to the cold end. Section of a metal bar in the steady state. 2. As a result, the temperature of every section of the rod starts increasing. 3. Under this condition, the rod is said to be in a variable temperature state. 4. After some time, the temperature at each section of the rod becomes steady, i.e., does not change. 5. The temperature of each cross-section of the rod now becomes constant though not the same. This is called a steady state condition. Exercises Q2. Sheet page 140. Answer the following question. Define coefficient of thermal conductivity. Solution. The coefficient of thermal conductivity of a material is defined as the quantity of heat that flows in 1 second between the opposite faces of a cube of side 1 meter, the faces being kept at a temperature difference of 1 degree Celsius or 1 K. Exercises Q2. Sheet page 140. Answer the following question. Give any 4 applications of thermal conductivity in everyday life. Solution. 1. A. Thick walls are used in the construction of cold storage rooms. B. Brick, being a bad conductor of heat, is used to reduce the flow of heat from the surroundings to the rooms. C. Better heat insulation is obtained by using hollow bricks. D. Air, being a poorer conductor than a brick, it further avoids the conduction of heat from outside. 2. Street vendors keep ice blocks packed in sawdust to prevent them from melting rapidly. 3. The handle of a cooking utensil is made of a bad conductor of heat, such as ebonite, to protect our hand from the hot utensil. 4. 2 bed sheets used together to cover the body help retain body heat better than a single bed sheet of double the thickness. Trapped air, being a bad conductor of heat, the layer of air between the 2 sheets reduces thermal conduction better than a sheet of double the thickness. Similarly, a blanket coupled with a bedsheet is a cheaper alternative to using 2 blankets. Exercises Q2. XIV, page 140. Answer the following question. Explain the term thermal resistance. State its SI unit and dimensions. Solution. Exercises Q2. XV, page 140. Answer the following question. How heat transfer occurs through radiation in absence of a medium. Solution. 1. All objects possess thermal energy due to their temperature T greater than 0 K. 2. The rapidly moving molecules of a hot body emit M waves traveling with the velocity of light. These are called thermal radiations. 3. These carry energy with them and transfer it to the low-speed molecules of a cold body on which they fall. 4. This results in an increase in the molecular motion of the cold body and its temperature rises. 5. Thus transfer of heat by radiation is a twofold process: the conversion of thermal energy into waves and reconversion of waves into thermal energy by the body on which they fall. Exercises Q2. XVI, page 140. Answer the following question. What is thermal stress? Solution. 1. Consider a metallic rod of length L0 fixed between two rigid supports at T°C. 2. If the temperature of rod is increased by delta T, length of the rod would become L equals L0, 1 plus add T, where alpha is the coefficient of linear expansion of the material of the rod. 3. But the supports prevent the expansion of the rod. As a result, rod exerts stress on the supports. Such stress is termed as thermal stress. Exercises Q2. XVI, page 140. Answer the following question. Give an example of the disadvantages of thermal stress in practical use. Solution. Disadvantage. Thermal stress can lead to fracture or deformation in substance under certain conditions. Example. Railway tracks are made up of metals which expand upon heating. If no gap is kept between tracks, in hot weather, expansion of metal tracks may exert thermal stress on track. This may lead to bending of tracks, which would be dangerous. Hence, railway track is not a continuous piece but is made up of segments separated by gaps. Exercises Q2. XVI, page 140. Answer the following question. Which materials can be used as thermal insulators and why? Solution. 1. Substances such as glass, wood, rubber, plastic, etc. can be used as thermal insulators. 2. These substances do not have free electrons to conduct heat freely throughout the body. Hence, they are poor conductors of heat. Exercises Q3. Page 140. Solve the following problem. A glass flask has a volume 1 times 10 to 4 m3. It is filled with a liquid at 30 C. If the temperature of the system is raised to 100 C, how much of the liquid will overflow? Coefficient of volume expansion of glass is 1.2 times 10 to 5 C minus 1, while that of the liquid is 75 times 10 to 5 C minus 1. Solution. Equals 75 times 10 to 5 times 10 to 4 times 100 to 30. Equals 75 times 70 times 10 to 9. Equals 5250 times 10 to 9 m3. Therefore increase in volume of liquid equals 5250 times 10 to 9 m3. Therefore volume of liquid which overflows equals 5250 84 times 10 to 9 m3. Equals 5166 times 10 to 9 m3. Equals 0.5166 times 10 to 7 m3. Volume of liquid that overflows is 0.5166 times 10 to 7 m3. Exercises Q3. Page 140. Solve the following problem. Which will require more energy? Heating a 2.0 kg block of lead by 30 K or heating a 4.0 kg block of copper by 5 K? Sleet equals 128 jkg 1 K1. Copper equals 387 jkg 1 K1. Solution. Given M lead equals 2 kg, delta T lead equals 30 K, sleet equals 128 J per kilogram K, MCU equals 4 kg, delta TCU equals 5 K, SCU equals 387 J per kilogram K. To find substance requiring more heat energy. Formula. Q equals Ms delta T. Calculation. From formula. For lead, Q lead equals 2 times 128 times 30 equals 7680 J. For copper, QCU equals 4 times 387 times 5 equals 7740 J. QCU greater than QLED. Copper will require more heat energy. Copper will require more heat energy. Exercises Q3. E page 140. Solve the following problem. Specific latent heat of vaporization of water is 2.26 times 106 J per kilogram. Calculate the energy needed to change 5.0 grams of water into steam at 100 C. Solution. Given LVAP equals 2.26 times 106 J per kilogram, M equals 5 grams equals 5 times 10 minus 3 kilograms. In this case, no temperature change takes place and only a change of state occurs. To find heat required to convert water into steam. Formula. Heat required equals mLVAP. Calculation. From formula. Heat required equals 5 times 10 to 3 times 2.26 times 106. Equals 11,300 J. Equals 1.13 times 104 J. Heat required to convert water into steam is 1.13 times 104 J. Exercises Q3. IV page 141. Solve the following problem. A metal sphere cools at the rate of 0.05 Cs when its temperature is 70 C and at the rate of 0.025 Cs when its temperature is 50 C. Determine the temperature of the surroundings and find the rate of cooling when the temperature of the metal sphere is 40 C. Solution. Exercises Q3. B page 141. Solve the following problem. The volume of a gas varied linearly with absolute temperature if its pressure is held constant. Suppose the gas does not liquefy even at very low temperatures. At what temperature the volume of the gas will be ideally zero? Solution. At temperature of minus 273.15 C, the volume of the gas will be ideally zero. Exercises Q3. B page 141. Solve the following problem. In olden days, while laying the rails for trains, small gaps used to be left between the rail sections to allow for thermal expansion. Suppose the rails are laid at room temperature 27 degrees Celsius. If maximum temperature in the region is 45 degrees Celsius and the length of each rail section is 10 meters, what should be the gap left given that alpha equals 1.2 times 10 to 5 K minus 1 for the material of the rail section? Solution. Given T1 equals 27 degrees Celsius, T2 equals 45 degrees Celsius, L1 equals 10 meters. Alpha equals 1.2 times 10 to 5 K. To find gap that should be left, L2L1. Formula. L2L1 equals L1 alpha T2 T1. Calculation. From formula. L2L1 equals 10 times 1.2 times 10 to 5 times 45 to 27. Equals 2.16 times 10 minus 3 meters. Equals 2.16 millimeters. The gap that should be left between rail sections is 2.16 millimeters. Exercises Q3. B page 141. Solve the following problem. A blacksmith fixes iron ring on the rim of the wooden wheel of a bullock cart. The diameter of the wooden rim and the iron ring are 1.5 meters and 1.47 meters respectively at room temperature of 27 degrees Celsius. To what temperature the iron ring should be heated so that it can fit the rim of the wheel? Alpha iron equals 1.2 times 10 to 5 K minus 1. Solution. Exercises Q3. B page 141. Solve the following problem. In a random temperature scale X, water boils at 200 degrees by and freezes at 20 degree X. Find the boiling point of a liquid in this scale if it boils at 62 degrees Celsius. Solution. Here thermometric property P is temperature at some random scale X. Using equation. Exercises Q3. X page 141. Solve the following problem. A gas at 900 degrees Celsius is cooled until both its pressure and volume are halved. Calculate its final temperature. Solution. Exercises Q3. X page 141. Solve the following problem. An aluminium rod and iron rod show 1.5 meters difference in their lengths when heated at all temperature. What are their lengths at 0 degrees Celsius if coefficient of linear expansion for aluminium is 24.5 times 10 to 6 per degree Celsius and for iron is 11.9 times 10 to 6 per degree Celsius? Solution. Given LT equals 1.5 meters, T0 equals 0 degrees Celsius, alpha Al equals 24.5 times 10 to 6 per degree Celsius, alpha I equals 11.9 times 10 to 6 per degree Celsius. To find lengths of aluminium and iron rod L0 Al and L0 I. Formula. LT equals L0, 1 plus alpha T, T0. Calculation. For T0 equals 0 degrees Celsius from formula, LT equals L0, 1 plus alpha T, for aluminium, LT Al equals L0 Al, 1 plus alpha Al T. Ellipsis. Opening parenthesis. 1. For iron, LT I equals L0 I, 1 plus alpha it. Ellipsis. Opening parenthesis. 2. Subtracting equation 2 by 1. LT I equals LT Al equals L0 I plus L0 I alpha it L0 Al plus L0 Al alpha Al T
يساوي L0 I L0 عال زائد L0 أي ألفا I L0 عال ألفا عال T 1.5 يساوي 1.5 زائد L0 أي ألفا I L0 عال ألفا عال T.
Rightwards double arrow L0 I alpha I L0 Al alpha Al T equals 0.
L0 عال ألفا عال يساوي L0 أي ألفا I L0 عال يساوي L0 أي ألفا I.
Exercises Q3. Sheet page 141. Solve the following problem. What is the specific heat of metal if 50 calories of heat is needed to raise 6 kilograms of the metal from 20 degrees Celsius to 62 degrees Celsius? Solution. Exercises Q3. Sheet page 141. Solve the following problem. The rate of flow of heat through a copper rod with temperature difference 30 degrees Celsius is 1500 calorie per second. Find the thermal resistance of copper rod. Solution. Exercises Q3. Sheet page 141. Solve the following problem. An electric kettle takes 20 minutes to heat a certain quantity of water from 0 degrees Celsius to boiling point. It requires 90 minutes to turn all the water at 100 degrees Celsius into steam. Find the latent heat of vaporization. Specific heat of water equals 1 calorie per gram degree C. Solution. Exercises Q3. XIV, page 141. Solve the following problem. Find the temperature difference between two sides of a steel plate 4 cm thick, when the heat is transmitted through the plate at the rate of 400 kcal per minute per square meter at a steady state. Thermal conductivity of steel is 0.026 kilocalories per meter SK. Solution. Exercises Q3. XV, page 141. Solve the following problem. A metal sphere cools from 80 degrees Celsius to 60 degrees Celsius in 6 minutes. How much time would it take to cool from 60 degrees Celsius to 40 degrees Celsius if the room temperature is 30 degrees Celsius? Solution.
What?